Okay, so we continue and solve the system of linear congruence equation. Just we did in the last part of the video. So now we want to solve the problem x congruent to 2 modulo 3, x congruent to 3 modulo 5, and x congruent to 2 modulo 7. So that is a system of three linear congruence equation. So how can we solve it? So let me just okay, so this is the solution. Now actually, even though we have three equations, the method is just very similar to the case when we have two equation. Yeah, two equation. So here we consider the system. Okay, so instead of solving x, we try to solve three other variables, namely a, b, and c. So a, okay, so small letter a. Now a has to be congruent to 2 modulo 3, and a congruent to 0 modulo 5, and a congruent to 0 modulo 7. So this is the first system, which is for a. Okay, and then we have another variable which is b. In this case, b has to be congruent to 0 modulo 3, and b congruent to 3 modulo 5, and the final one is b congruent to 0 modulo 7. Okay, so this is the second system for b. Now the final one is for c, and you can see we have this, and okay, so we got the three system, and the key, okay, in constructing these three systems is just, you know, you keep one of the equation. So every system has a common equation compared with x, except that, okay, the other two equations are just congruent to 0. So for example, a is congruent to 2 modulo 3, okay, which is the same as the first equation for x, and the other two I take it to be 0, okay. And for b, I keep the second one, so that's why you see b congruent to 3 modulo 5. And for the case for c, I keep the last one, so that's why c congruent to 2 modulo 7. Okay, so this is exactly the same method we did for the case for two equations, but now we have three, so that's why we have three variables. Okay, so three variables a, b, c. Now if we, okay, after we find a, b, and c, okay, the general solution for x is just given by this. Okay, so you just take a plus b plus c, okay, and then because here I have to get the general solution, so you have to give me all the solution. So a plus b plus c is just one solution. Okay, so you can check. Okay, after you take the sum, okay, you take the sum, then that x will satisfy the original system. Okay, but it's not the general solution because you just have one solution only. So that's why you have to add something at the back, which is the LCM of 3, 5, and 7, and then you multiply that by k. Okay, so k being any integer. Okay, so if you do that, that will give you all the solution. Okay, all the solution for x. So you can even simplify it a little bit, because you can find the LCM for 3, 5, 7 explicitly and that give you 105. Okay, 105 times k. Okay, so that means if you can get A, B, and C, you're done, because the general solution is just the sum, and then you add it to 105 times k, and that's it. That is the general solution. So how can you get A, B, and C? Well, again, the method is just similar to the case for two linear equations. And in fact, if you understand the method for finding A, okay, actually for B and C, they are just similar. Okay, so let's just start with A. Okay, so to find A, now since A is congruent to 0, modulo 5, not just that, we have two, okay, A congruent to 0 modulo 5 and A congruent to 0 modulo 7. Okay, so we have two conditions which is equivalent, which is congruent to 0. Okay, of course, we have different congruence, okay, 5 and 7, but both of them turns out to be 0. Okay, now if you consider these two equation, you can say equation or conditions, well, that will give you this. Okay, so we have A equals to 35 times n. Let's say capital A. Okay, so A is just 35 times A for some integer A. Why? Well, you just plug in, okay, because now this two equation telling you what? Telling you that A has to be a multiple of 5. At the same time, it's also a multiple of 7. So how can it be? Well, because 5 and 7, they are relatively prime. Okay, so you just take the LCM, that is 35, and that will give you this. So that's why A must be both. A must be a multiple of 35, which is the multiple of both 5 and 7. Okay, for some integer capital letter A. Now, once you get it, okay, then you just put it into the first equation. So therefore, we have 35 capital letter A, that is congruent to 2 modulo 3. Okay, so that is exactly the first equation for A here. Okay, so that's why now you just have to solve that capital letter A. Okay, once you get capital letter A, then you get small letter A as well. So now you have so many different ways to solve it, or you can even try it by inspection. Okay, so for example, you take A equal to 1. Okay, then you can check that 35 times 1, that is equal to 35, of course, but that is also congruent to 2 if you are taking the congruence modulo 3, because 35 minus 2 is 33, okay, which is a multiple of 3, so that's why 35 is congruent to 2. So that's true. So we can take small letter A to be 35 times 1, which is 35. Okay, so that is the case for A. So you just have to get one solution for A. Okay, and that's enough. Okay, because you don't have to get the general solution for this problem, because you just have one particular solution for you. Okay, in getting X. Okay, so that's why that's enough. You just get the small letter A. Okay. Now, for example, how can you get the small letter B? Okay, so actually everything are very similar. So let me just copy this part. Okay. Now, instead of finding A, now if you want to find B, okay, so now you look at B. Okay, so B is congruent to 0 modulo 3, so I have to change this. Okay, and then B is congruent to 0 modulo 7, so I change that. Okay, so actually, okay, so we have this two equation, which is 0. So actually every time we just look for those equations which is which are congruent to 0, okay, because that will give you a very simple form for the number, okay. For example, here because b has to be congruent 0 modulo 3 and congruent 0 modulo 7, so b must be now a multiple of 21 because the LCM of 3 and 7 is 21, so it must be a multiple of 21. So that means b is equal to 21 times capital letter B for some integer. Now I use another symbol, capital letter B. Okay. So therefore, we can substitute this back to the final equation, which is not 0. So here b is congruent to 3 modulo 5. So that's why we have 21b. Which is congruent to 3 modulo 5. Okay, so that's why we need to solve this final equation for b, for capital letter B, I mean. Now you can easily solve it. For example, you take capital letter B equal to 3. Okay, then you can check that. Okay, then you get 21 times 3. That give you 63. And 63, if you subtract 63 by 3, that gives you 60. And 60 is congruent to 0 modulo 3. So that's why 63 is congruent to 3 modulo 3. Okay? So therefore, you can take small letter b to be 21 times 3, which gives you 63. Okay, for this case. So we got the value for b as well. Okay, actually you see the method is exactly the same. Okay, for solving b, if you compare that to the method in solving a. Now for the final case for c, again I copy and paste. Okay, to find c. Okay. Now these are the equation for c, right? So here you have to again taking care of those equations which are congruent to 0. So c is congruent to 0 modulo 3, c is congruent to 0 modulo 5. Okay. So because of that, we have c equal to 15 times capital letter C for some integer c. So therefore, this case we get, now you put it back to the final equation, c congruent to 2 modulo 7. Okay, so here you have 15c. Okay. Okay, so we got it. Now you just have to solve this equation, and well, you can again try and error. Usually you just try some small numbers and see if it works or not. For example, if you take capital letter C to be 2, then the left hand side here gives you 30. Okay, you just compute that directly. And 30 is congruent to 2 modulo 7, because 30 minus 2 is 28. Okay, so that's why they're congruent. And we have C, this time we have 15 times 2, and that is 30. Okay, so we got all the values for A, B, and C. Okay, so we got it. So therefore x now is just the sum of A plus B plus C. Remember, plus 105 times k, k being any integer. Okay, and here that will give you, okay, you add up the three numbers. Okay, the three numbers will give you 128. Okay, which is this. Okay, so you solve the problem. Okay, now this is exactly the method in solving three linear congruence equation at the same time. Okay, and It's not that difficult, but you just have to be patient, okay, and try to do it step by step, okay. So there are let's see. Yeah, there are some remarks. Okay, I will give you some final remarks for this system of linear congruence equation in the last part of the video. Okay.